Good evening, everyone. Let me introduce myself. My name is Monika Stankiewicz, and I'm the Executive Secretary of the Minamata Convention. Welcome to the session on Article 8 of the Minamata Convention on emissions. The session is organized within Minamata Online, which is a series of briefings focusing on the review and support to the convention implementation, on Mercury science, and on the preparations to the fourth meeting of the Conference of the Parties to the Convention that will take place next year. Please note that this session is being recorded, and recording will be made available on the Minamata Convention website. If in case you experience any technical problems, please use the chat box to communicate those, and we'll try to assist you as much as we can. We would also encourage, or would like to encourage you to post any questions in the questions and answers box. We will try to answer your questions at the second part of our event. The topic for today's information session is mercury emissions to the atmosphere and how the convention address them. As you know, mercury circulates globally in the atmosphere and is often deposited to land and water far from where it was emitted. And in marine and freshwater ecosystems, mercury will transform to its most toxic form, metal mercury. And the most detrimental effects of mercury pollution are manifested when marine and freshwater fish and mammals contaminated with metal mercury are consumed by humans, leading to serious and adverse health effects. Contaminated seafood may have also negative impacts on fisheries and economy. The first global mercury assessment was done by UNEP in 2002, and this assessment demonstrated that this is a global problem, and that was later also confirmed by the UNEP Governing Council. This recognition that mercury is a global problem that cannot be solved by countries alone is the historical underpinning of the Minamata Convention. Next slide, please. And with this graphic, I would like to show you the model deposition of mercury that was part of the 2018 update of the Global Mercury Assessment, illustrating the global impacts of mercury that is deposited nearly in every place on the globe. Next slide, please. And mercury emissions result from natural, re-emitted, or anthropogenic sources. The Convention's Article 8 addresses mercury emissions from the sources listed in Annex D, these anthropogenic sources. And you can see the magnitude of emissions here with the coal combustion on top of the list. Other articles of the Convention cover mercury uses, which also may lead to emissions, such as artisanal and small-scale gold mining, which is the largest source of global mercury emissions, the manufacturing and disposal of mercury-added products, and mercury-based industrial processes. However, the topic for today is Article 8, which is specific to controlling the emissions of mercury that are sometimes referred as unintentional or not as a result of intentional use of mercury. And for example, coal contains mercury as a natural impurity. A significant amount of mercury is therefore released into the atmosphere and environment from coal combusted in coal-burning power plants and industrial boilers. Metal ores and limestone also contain naturally occurring mercury, which can be emitted during metal smelting and cement manufacturing, in addition to mercury which may be released from the fuel sources. And without controlling these emissions, the Minamata Convention will not be successful. So today we want to give you the basic elements of Article 8 control measures and guidance for implementation. My Secretariat colleagues will shortly be joined today by Lesley Sloss of the International Energy Agency. She and Peter Nelson of Macquarie University in Australia are co-leads of the Global Mercury Partnership Coal Combustion Area and have been global leaders on the issue of mercury emissions. We thank the partnership and Lesley and Peter in particular for the important work. Now I'm handing over to my colleague Marianne Bailey, who will continue with the presentation. Thank you so much.
Thank you, Monika. Here in this slide, we can just see the overview of what we'll cover today in a bit more detail. I'll cover the basic provisions of Article 8, and then some more technical information about guidances and practices will be covered by Eisaku and Lesley. So launching right into the next slide, I want to talk about the scope of Article 8. Article 8, and this is from the very first paragraph of the article, it concerns controlling and, where feasible, reducing emissions of mercury and mercury compounds, often expressed as total mercury, to the atmosphere through measures to control emissions from the point sources falling within the source categories listed in Annex D. So what is listed in Annex D? You can see here that it is these 5 sources: coal-fired power plants, coal-fired industrial boilers, smelting and roasting processes used in the production of non-ferrous metals, waste incineration facilities, and cement production facilities. So that is the scope. Next slide, please. In paragraph 3 of the convention, we have the very basic obligation, which is that a party with relevant sources shall take measures to control emissions. So the specific type of measures are described in the text, and I'll go into a bit more detail on that in a moment. But I want to note that paragraph 3 goes on to say that a party may prepare national plan setting out the measures to be taken to control emissions and its expected targets, goals, and outcomes. But such a plan is not mandatory under the convention. If a party chooses to prepare such a plan, it's to be submitted to the COP within 4 years of when the convention enters into force for that party. Now, national environmental and air pollution laws are the most likely types of policies that a country would use to implement the Article 8 obligations. Facility emissions reporting to facilitate inventories may be covered by release reporting or pollution registry laws in a country. So, so the basic control measures include measures for new facilities, measures for existing sources, and the mercury emissions inventory that needs to be established and maintained. Next, please. So for 2 of the emissions source categories, it's useful to discuss what subcategories of those look like. For waste incineration, those facilities typically would encompass medical waste, municipal waste, hazardous waste, or sewage sludge incineration. And those are not specifically mentioned in the convention, but those are what you would typically find in practice. For non-ferrous metals, the subcategories are noted in the convention Annex D, and those are lead, zinc, copper, and industrial gold. So it's not every type of non-ferrous metal production, but those are the ones that the negotiators deemed as the most critical for control under the convention. In the next slide, there is a provision in the convention that provides an option for governments for the control of these sources. So under this provision, governments may choose not to regulate every facility within a source category, provided the sources that they do regulate account for at least 75% of the emissions within the category. So this flexibility can be particularly useful where the country has many sources of varying characteristics within a category. So, but not all those sources would contribute significantly or equally to the total emissions from the category. So for example, in some countries, coal-fired industrial boilers could be such a category because they might vary in degree and size and types of equipment and that sort of thing. So that is an option for countries, and there is guidance on that, which we'll touch on briefly. And now moving on to the convention's distinction between new sources and existing sources. A source is considered new when the construction begins 1 year after the convention enters into force for the party. And then the deadline for applying the controls is 5 years after entry into force. So I'll just read out the actual paragraph 4. For its new sources, each party shall require the use of best available techniques and best environmental practices, or BAT-BEP, to control and reduce emissions as soon as practicable, but no later than 5 years after the date of entry into force. A party may use emission limit values that are consistent with the application of best available techniques. So the control options are BAT-BEP or consistent ELVs, emission limit values. So just to repeat, for new sources, parties must apply BAT-BEP to control emissions or set emission limit values consistent with BAT as soon as practicable, but no later than 5 years after the convention enters into force for that party. And my colleague Eisaku is going to discuss the guidance on BAT-BEP in detail. So even though compliance with BAT-BEP is not required until 5 years after the convention comes into force, which for many of our parties is 2022, the definition of a new facility applies to facilities starting construction after just 1 year. So as a practical matter, facilities identified as new should be designed, constructed, and operated to meet BAT-BEP from the start. In the next slide, we'll talk about the provisions for existing sources. In paragraph 5, the convention says for its existing sources, each party shall include in any national plan and shall implement one or more of the following measures as soon as practicable, but no more than 10 years after the date of entry into force. So any relevant source that is not new is considered existing, and there's a 10-year deadline for applying controls to these sources. There's 5 options for doing that, identified in the convention text, and those are a quantified goal for controlling and, where feasible, reducing emissions for relevant sources, emission limit values for controlling and, where feasible, reducing emissions from relevant sources, the use of BAT-BEP to control emissions from relevant sources, a multi-pollutant control strategy that would deliver co-benefits for control of mercury emissions, and the last choice is alternative measures to reduce emissions from relevant sources. And a party can choose different options for each of the 5 source categories in Annex D, and for individual sources within the source category. So note that only the 5th option, and that's the alternative measures, requires reduction, while the other options specify control and reduction where feasible. The guidance for defining BAT-BEP and issuing ELVs mentioned above applies to existing facilities, as mentioned. So the selection can vary between new and existing sources. And a multi-pollutant control strategy refers to a strategy that takes advantage of optimizing existing air pollution control originally installed to control other pollutants such as particulate matter, SOx, NOx, that type of thing, in order to capture mercury as well. A multi-pollutant control strategy can be particularly useful where governments are considering regulating a source category for a range of pollutants. And by addressing all the pollutants at once, the government can consider the air pollution control equipment necessary to address these and determine the level of mercury emissions control achievable and how the performance of the equipment can be optimized. So my colleagues will go into much more technical detail on that than I am able to. In the next slide, another provision in the convention is that each party shall establish, and as soon as practical, and no later than 5 years after the date of entry into force of the convention for the party, and maintain thereafter an inventory of emissions from relevant sources. So again, develop the emissions inventory within 5 years and maintain it thereafter. So there is guidance on this, and a UNEP toolkit for estimating emissions can be found on our website link, and towards the end of this, we will provide links to those type of things. And Article 8 in the next slide includes a provision to report to the COP on what they're doing under Article 8. So each party needs to report on the measures it has taken and the effectiveness of the measures. The first full reports by parties are due in December of next year in 2021. We had short reports that were due last December, which didn't include the Article 8 reporting, but the next year reporting does include Article 8 reporting. So those are going to be very important and very instructive for us all as we look at those reports in the future. So finally, just in summary, those were the basic and complete provisions of Article 8. The text, of course, includes more detail, and I encourage you to read the text carefully, but I hope I've summarized it okay for you. It is BAT, BEP, or associated ELVs for new facilities, measures selected to control and where feasible reduce mercury emissions from existing sources, and establish, maintain a mercury emissions inventory. So with that, I would like to turn this over to my colleague Eisaku Toda, who will provide much more in-depth and technical information focused on the guidances that the COP has approved. Thank you.
Thank you, Marianne. Since the time is quite limited, I will not be able to provide all the full details of the technical guidance documents, but I would like to briefly explain what the guidance, the technical document are about. And I'd like to remind you that any questions, if you have any questions, you should type it in the Q&A box so that the panelists can see it. I think while listening to the to our presentations, you can even start typing in your questions so that we can start handling the questions after the presentations. So coming back to the slide, I'm presenting the technical guidance documents adopted by the Conference of the Parties at its first meeting in 2017. These documents were developed by an expert group established by the Intergovernmental Negotiating Committee and finalized through public comments. There are 4 documents, as you see in the slide, including BAT-BEP guidance document at the top and the emission inventory at the bottom. So on the next slide, please. I would like to start from the inventory guidance because perhaps the identification of sources and identifying the emissions may be the first step for parties to start addressing and implementing the Article 8. And Marianne spoke about the convention requirements on emission inventories. It is to be established within 5 years after the entry into force, which is 2022 for the early parties. I think we may receive some early inventory as part of the Article 21 reporting next year. Next slide, please. So the guidance describes the general steps for establishing inventory, starting with the planning of the approach to to estimate the emissions and collect existing emissions data, and then, the identify relevant sources, establishing facility-based emissions reporting requirements. Some parties may already have a legal requirements under the pollutant register and transfer pollutant releases and transfer register (PRTR) or any other laws. And the collecting the emissions report from facilities on periodic basis, and the guidance mentioned several techniques that can be used, such as the direct measurements of emissions or emissions factors based on indirect measurements or engineering estimates or mass balance approach. So this guidance provides a brief advice on how to establish the emission inventory. We have a UNEP inventory toolkit. The link is provided in the presentation. This presentation will be shared, posted on the website after this session, and the UNEP toolkit provides the default emission factors and some data for parties to establish their own emission factors. Next slide, please. So then I would like to go to the BAT-BEP guidance. The BAT-BEP guidance starts with the general chapters and provide technical information on each of the 5 source categories listed in Annex D, as Marianne mentioned: coal-fired power plants, coal-fired industrial boilers, smelting, roasting for the non-ferrous metals, waste incineration, and cement clinker production. Next slide, please. The introduction to the BAT-BEP guidance sets as follows. This document presents guidance related to BAT and BEP to assist parties in fulfilling their obligations under Article 8. The guidance does not establish mandatory requirements, nor does it attempt to add to nor subtract from a party's obligation under Article 8. In determining BAT, each party will take account of its national circumstances. It is recognized that some of the control measures described in this guidance may not be available to all parties for technical economic reasons. Financial support, capacity building, technology transfer, or technical assistance are made available as elaborated in Articles 13 and 14 of the Convention. So, in essence, this is not mandatory, and this is something that parties is invited to take into account. And also, I would like to mention that the COP decision that adopted the guidance requests parties with experience in using these guidance to provide the Secretariat with information on that experience, and the Secretariat to compile such information and to update the guidance as necessary. So we would welcome any information from parties. Next slide, please. So this slide is a definition of BAT-BEP. Best available techniques means those techniques that are the most effective to prevent and reduce emissions and release of mercury. Best environment practices means that the application of the most appropriate combination of environmental control measures and strategies. Next slide, please. So in the introductory section, the guidance describes the general steps for selecting and implementing BAT-BEP. Step 1 flows from the emission inventory. Next slide, please. So I will briefly mention the specific technologies that are explained in the guidance document. Firstly, for coal combustion, the most important technology is the use of the air pollution control systems for other pollutants such as sulfur oxides, nitrogen oxides, and particulates, as mentioned in the point 3 of this slide. Elementary mercury vapor is not much removed from these systems, but much of mercury in flue gas exists in an oxidized form, and some are oxidized in the selective catalytic reduction system, SCR, mentioned in this chart. So, and then these oxidized mercury are removed in the electrostatic precipitators of flue gas desulfurization or the fabric filters. So this is the main component of the mercury reduction measures actually used in many plants. Next slide, please. The best combination of these systems may lead to a very low mercury concentration, even less than 1 microgram per cubic meters. But under actual conditions, it may not be sufficient to meet very strict emission standards as those in the US and EU. In some cases, activated carbon, as explained here, is needed to further remove mercury from the flue gas. And also, I'd like to point out that it is very important to use the best environmental practice. Air pollution control systems should not only be set up, but also be maintained and optimized. Next slide, please. So moving, we organized a capacity building workshop on mercury reduction from coal combustion in Hanoi last year with the participation of China, India, Indonesia, Mongolia, Sri Lanka, Thailand, and Vietnam. As Monika showed in the 4 pie charts earlier, Asia is the major source of emission from stationary sources, more than 2/3 for coal and so on. So the Asia is very important. Next slide, please. In this workshop, we heard, next slide, yes. In this workshop, we heard about the limit values already established in these countries, and it is very good to learn that these are already done. The 0.03 microgram, which is 30 milligrams, which is 30 micrograms, is a bit more, much higher than what the best combination of technology can achieve, but and also higher than the regulation in some developed countries, but these limit values are also complemented by pollution permits and technical specifications and so on. Next slide, please. So I move on to the non-ferrous metals, and emission from non-ferrous metals production is quite different. Mercury is emitted from process involving the heating of the ore or the concentrate, much of it being elemental mercury vapor. The guidance document describes specific technologies to remove mercury from off gas. The documents describe advice for selecting technologies for fit for or different processes. Next slide, please. Waste incineration, it's similar to coal, and perhaps waste input control is more important. Mindful of the time, I will accelerate. So I will go to the next one, cement, which is, next slide, please. Yes, the cement also similar to waste, and it is, of course, the flue gas control is important, and also the input control is very important. Next slide, please. So, and there are other guidance documents on Article 8. The first one, guidance and criteria relating to relevant sources. So to select identify the individual relevant sources so that these sources cover more than 75% of the emissions of that category, and the guidance says that you should take into account the size of the facility, mercury emission amount, expected life of the facility, location, area, and so on. And the second guidance is on the support for parties in implementing measures for existing sources. And as Marianne mentions there parties that to choose from 5 options, and the guidance provides advice on selecting options and establishing, for example, the BAT-PEP requirements or the emission limit values and so on. The last one, the fifth and alternative measures to reduce emissions from relevant sources. These includes, for example, shutting down old plants. Next slide, please. So, yeah, I think, next slide. Should be up. I think there was a slide on the links to the guidance, but I think this was inadvertently removed. But the slide deck to be posted on the website will include a link to the guidance documents that I referred to. So with that, I would like to turn to invite Lesley Sloss, the co-lead of the Global Mercury Partnership Coal Combustion Area, who just arrived from different other meeting. Thanks, Lesley.
Thank you, Eisaku. And yes, apologies for arriving late. Everybody wants online meetings these days, don't they? Anyway, it's an honour to be here to present today. And as already mentioned, coal is one of the major sectors to be dealt with under the Article 8 of the Minamata Convention. I've only got a short period of time to take you through this, so my personal details will be on the last slide, and I will be more than happy to answer questions that come up. Next slide, please. Now, as discussed by Eisaku, Article 8 deals with emissions from all coal-fired plants, but it separates them by age. New plant is anything which comes into operation 1 year or more after the date of ratification, and the existing units are all the other older ones which have been running for a while. The compliance measures for these two groups are quite distinct. New plants must install BAT-PEP, the best available technology, whereas older plants have more of a choice. And obviously the definition of BAT-PEP will vary according to the plant, all sorts of factors such as the type of coal burned, the type of boiler, control technologies and so on. And so the UNEP's guidance document shown on the right there really is quite a big thick document, and it gives expert advice on each of the options. However, it's not prescriptive. It's not going to tell you exactly what to do. Instead, it acknowledges that determining how to control mercury requires expert knowledge and detailed assessment of your plants. Now, for new plants, BAT-PEP for all pollutants should be being built into the design of the plant. Next slide, please. Coal plants are now edging towards being 10 to 15 percentage points more efficient than most of the plants we know of today. The average coal fleet plant that you would walk past in the street or wherever is about 35% efficiency maximum. A lot of them are older and less efficient than that. The new technologies that are coming out are significantly more efficient. This means like plants like Wagaochao there in China releases over 1/3 less emissions for the same amount of power produced than most other plants. Now, these advanced technologies are being installed around the world, and they're built automatically with flue gas control technologies in there. Nobody would build an ultra-supercritical plant without putting an FG system on as standard. And so low emissions are coming as standards. And many countries that plan to keep coal as part of their energy mix will be building these new HELI technologies rather than installing the older models. And a lot of countries are actually proposing a 25-year time horizon or age horizon for their plants. So as soon as an older subcritical plant reaches 25 years old, it has to be replaced by something more advanced. And this is automatically building in cleaner technologies into the future. And so for BAT-PEP and new plants should be covered in any healthy clean energy technology and energy national energy action plan, So BAT-PEP on new plants should come as standard is what I'm trying to say there. Next slide, please. For existing plants, these are plants that are different formats, CFBC, supercritical, subcritical, a lot of different challenges, a lot of different designs. Next slide, please. And so choosing the best available technologies for these plants does require a lot of information. It's important to stress that mercury emissions from a poorly controlled plant and those from a well-controlled plant can be hugely significant, and it can be easy to tell which plants are going to be clean and which are not. Uncontrolled plants could release up to 90% of the mercury going into the plant of the coal into the air without it being captured anywhere, whereas other plants may be automatically capturing up to 95% mercury in the ash or in the gypsum. So we have to understand that this is variable plant by plant basis, and there's no one silver bullet technology that's going to be applied to make sure that plants control all their mercury emissions, hence the BATBEP document being so complex. And on the right there, there's a little sort of, I don't know if you can see it, a table which shows the different approaches and tries to give an indication of the relative cost of each. But again, it's a variable on a plant-by-plant basis. And so you really need to look at your plants and understand what's going on before you make any important decisions. Next slide, please. So the overview of Article 8 is that existing sources, as we see at the bottom there, have to be controlled, but also a mercury emissions inventory has to be prepared. And combining these two can be potentially the key to sorting this problem. Project that I'm involved in, the IEA Clean Coal Centre, is addressing both of these last two tick boxes simultaneously. So on behalf of the US Department of State, I've not reduced the results yet, so I'm going to show you some results without any labels attached, and I'm not going to mention which country we're involved with until we're allowed to release that data. But hopefully I've given an indication of how Article 8 can work in practice. Next slide, please. So there's no way around it. In order to define BATBEP, you really need to take a close look at your fleet, and you have to do some number crunching. Once you've built an inventory for that fleet, however, it's much easier to maintain, and it's vital for sectoral emission management. So basically, you build a data set, a database, a spreadsheet, whatever you want to call it, and you collate all your information into that one format, and then you build in calculations to reproduce your emission values for that fleet. So you need a list of all your plants in your country, and you need data for those plants, the capacity, the coal use, the control technologies, and so on. It is a bit of work, especially for countries with many coal units. However, once you have that, it is much easier to update annually to create a rolling inventory over time, and the same data set can be used to predict future emissions based on expected growth in the field, or it can be used to monitor the success of any emission reduction policies which are put into place. Next slide, please. Now, emission calculations may look like hard sums, but trust me, if I can do them, they're not. What you need is an emission factor, that is the amount of mercury in your coal that's going into your plant, multiplied by the activity value, that's the amount of coal that's being burned. So that's how much of the mercury is going to come out of your plant over a year, unless you do something about it. This RF factor is the reduction or the retention factor, and that is how much of the mercury is going to stay within the plant in any control technologies. So that will actually reduce the maximum amount of emissions coming out of your plants. And what you do is you look at your different plants. So I've got very simply got plant A and plant B here, both burning exactly the same coal, which makes it easier. But plant A is burning twice as much coal, 100 kilotons per year, as opposed to 50 for plant B. So perhaps looking at that, you would expect plant A to produce more mercury. However, plant A is installed with electrostatic precipitators, flue gas desulfurization, woofers and tweeters, so it's reducing its mercury emissions automatically by 80% or more. And so its emissions are actually lower than those from plant B, which is only installed with a fabric filter. And so this kind of information lets you know which plants would actually be better for approaching for control technologies. Next slide, please. So we need to evaluate emissions on a plant-by-plant basis, as I've said, and the plants that we think are emitting the most may not be. This is where the IPOG is extremely useful, and I'm not going to go into great detail as there are plenty of webinars and reports on the IPOG available on our website. If you click through that complex link at the bottom there, you can actually download the IPOG and instructions on how to use it. Basically, it's a little exe file, a little calculation tool that has information for plenty of coal plants around the world, over 1,000, which can predict mercury emissions from a plant based on the control technologies in place. And so you can use the IPOC to predict your RF, your retention factor. It'll tell you how much mercury will be captured in your plant. And that is how you get a better emission value for your coal fleet. And then you identify the plants of most concern. So next slide, please. There are two ways you can rank your plants. You calculate their emissions on an annual basis, and that will come up on the right there. So plant A is emitting less on an annual basis than plant B. However, on the right, it's possible to look at emissions over the remaining plant lifetime, which is probably more important. So although plant A, as we know, is burning cleaner than plant B is 30 years old, plant A is only 5. And so plant A is going to continue running for 35 years or more, whereas plant B is probably going to close down within the next 10 years. And so although looking outside the plants, you may want to take action against plant B, it's actually more logical to take action against plant A. You're going to get more value and more mercury emissions in the long term for the same amount of money. Next slide, please. So this is some data that we've got from our country, and it's just to show you that it's nothing's ever as simple as you think it's going to be. These are emissions in the blue dots from different plants within this country, and what we can see is that the range of mercury emissions from each of these plants is quite big. Just because this plant is 600 megawatts and this is 300, there's no difference in how much mercury could come out of these plants. It depends on how they're operated, how much coal they combust, and so on. The same as on the right, the unit size does not relate to the amount of mercury emissions coming out on a megawatt hour basis. So basically, it's not correct to assume that your larger plants are responsible for larger emissions. You have to do more information search than that to get your facts right. Next slide, please. So what we did was to do this for the entire fleet of this country in question. And we put the blue charts lines there, show the emissions coming of mercury from each of the units in this country, from the top, I think, 30 ranking plants here. And so we can see that the top 10 to 12 ranking plants here are actually going to emit, over the remaining lifetime, more than the rest of the fleet put together. And so by taking action against these top few plants, we will actually reduce mercury emissions in this country significantly, rather than rolling out BAT-BEP ineffectively and possibly less cost effectively across the whole fleet. If anyone's interested, the little red dots are sulfur emissions for these plants, and this is going to help us define which plants would be appropriate for multi-pollutant control technologies. So the ones on the left there with high sulfur and high mercury, we will be going in with flue gas desulfurization and multi-pollutant control technologies, whereas any with lower red dots, we might go in with a mercury-specific control technology. And this is the power of understanding the fleet and getting your emission values. Spend the money where it is most appropriate for the money to be spent. Next slide, please. So I think my conclusion is the more you know, the easier it is to control your emissions. Plant and coal specific data are the key to defining your fleet and defining where action should be taken and what action could be taken. And that will make the difference between a very expensive, ineffective national strategy and an effective and cost-effective strategy. Next slide, please. This is my data. I know I talk very fast and I know I've covered a lot of technical stuff. So my email address is down the bottom there. I'll be more than happy to answer technical questions at any time. Thank you.
Thank you so much, Lesley, and Eisaku as well. I would like to encourage participants to enter questions in the Q&A box on the side of your screen on the right side. If you're having any technical difficulties with that, please go ahead and enter it in the chat. We can reach those as well. And we already have a couple, which I'll get to in a moment. But first, if we can advance to the next slide, I think we do have here's some resources you can turn to. And the presentations and the video of this should be posted to our website by the end of the week or Monday at the latest. And you will be able to use these links to get to the things you want to use. And also you can find an enormous amount of information on our website and on the website of the UNEP Global Mercury Partnership and other sources. And we're happy to answer any questions you might have on that, either today or in the future. You can feel free to contact the Secretariat. So turning to the first question that we have received. So what are the next measures? This is from Zygam Abbas. What will be the next measures for a new party under Article 8? And I'll just go ahead and answer that briefly, and then I'll turn to Eisaku if he wants to elaborate more. But the Article 8 provisions are timed based on the entry into force for that party. So your question is appropriate because the timing is not the same for everybody in the world, unlike our Mercury added products deadline or Mercury process deadlines. Under Article 8, you start counting from the time you become a party. So for the key provisions, the 5 years after entry into force for that country is the inventory requirement, as well as the requirement on new source controls. And then 10 years later, not 10 years from then, but 10 years from entry into force is the requirement for existing sources. Eisaku, do you want to add anything?
Yeah, thank you, Marianne. With regard to the timelines, one addition would be the 4 years, which is the submission of the action plan, but which is not mandatory. The parties may develop national action plans, but if they develop it, we expect it to be submitted 4 years after the entry into force. Thank you.
Okay. And to follow on also from Zygam, the question continues with whether a party would use the UNEP toolkit for measuring mercury emissions or mercury analysis from stacks. Can Eisaku, could you?
Yes, thank you very much. And UNEP toolkits have two. I forgot how the step 1, step 2. I forgot how. But the first one is the uses the default value, and since these point sources emit quite a large quantity of emissions, perhaps it may be better to develop a emission factors applicable to individual facilities, as Lesley mentioned. And the direct measurement, of course, it depends on the regulations of each country. Some countries may establish a continuous monitoring requirements for stack emissions, but for some countries it may they may choose not to introduce that requirement. So in that case, the emission factors may be derived from some sample monitoring from stacks, or perhaps the engineering consideration from the mercury content in coal and assumed efficiency of the air pollution control devices. So there are multiple ways for estimating emissions, but maybe Lesley have some advice from the technical point of view.
Yes, thank you. Yes, the emission factors provided by the toolkit are excellent if you just want to do a quick run of an inventory for a country. But if you're doing a sectoral analysis like we are doing, then I think what we are doing is the engineering one. So we know the mercury content of the coal, and we're using the IPOG to predict how much mercury capture is going to happen within the plant. We have used the third option where we've gone into South Africa, China, India, Russia and other countries and measured at the stack emissions. However, that's an expensive way of doing things unless we finally get to where there are mercury monitors on all the coal-fired power plants. Mercury monitoring at the stack is going to be quite laborious. And so Tier 1 with the emission factor is the easiest and quickest, but not accurate. Engineering is where we're at, and I propose that that's probably the best way if you want to do a detailed sectoral analysis. If you have the luxury of money and you can analyse at the stack, then please do so. However, a lot of countries will not be able to afford to do that.
Great, thank you. Well, we have a good question here from Satish, and he's asking how's the share of oxidized mercury enhanced in a combustion chamber for better recovery? And can you suggest some case studies? I'm not sure, but that is maybe a question for Eisaku to start and turn to Lesley as well.
Thank you very much. I think this is a quite difficult question to answer because I'm not sure about the technology to enhance oxidation in combustion chamber. I think the oxidation happens anyway, and perhaps the SCR, the selective catalytic reduction system, will enhance the oxidation, but I'm not sure about the enhancing the combustion chamber. But we will need to look for some good case studies. But perhaps I will need to turn to Lesley.
Yes, Saku's right. The oxidation happens in the boiler. It depends on the coal chemistry and the combustion conditions. Basically, mercury will oxidize if it's next to a halogen or some other oxidizing factor, and that will determine it. So you can change that in the combustion zone by blending coals, so that you've got coals with higher chlorine content in them, or you can actually add bromine or chlorine to the coal before it goes into the plant. I don't think it's ever sprayed into the boiler because that sounds, I could be wrong, but you can also spray it downstream post-combustion, upstream of the bag filter, the fabric filter, and hope to capture mercury in there, because as soon as it's oxidized, as we know, it's going to stick to any unburnt carbon into the ash, and it's going to be easier to capture. With respect to case studies, we've actually done this. There's a UNEP study in Russia where we took an industrial boiler and we added oxidant as a mix into the coal. And I think we might have sprayed it into the dusting chamber afterwards, and the enhancement was significant. There are quite a few studies out there, and there are a number of reports by myself on the Clean Coal Centre website or on the UNEP website that will include other case studies of oxidation.
Thank you. Great. Zycam is asking if we could elaborate a bit more on the 75% provision that I mentioned. Is that something you can comment on, Eisaku?
Well, yeah, I think what I would like to mention is that 75% provision is applicable when parties choose to take this approach by selecting, identifying the most important facility bases and take measures on these. The individual facilities, and of course parties may choose to establish a regulation which is applicable to all facilities under this category. So for example, if you establish a regulation which is applicable to the power plant above certain power producing capacity, you have to make sure that it covers 75% of the of that sector, the coal coal power plant sector. So I think I'm clear enough. Thanks.
Okay. I am not seeing any more questions in our panels here on the side. If I'm missing anything, one of my colleagues can let me know. But as we wind up, I do want to note the tremendous work of the expert groups that developed, in particular, the BAT-BEP guidance under the convention. And they met over the course of months and years, and they did tremendous work to develop the very thick and detailed guidance, as Lesley described it, and the other guidances as well. It's just there's a great deal of expert work has gone into this, and of course the UNEP Global Mercury Partnership has also done a tremendous amount of work that you can all benefit from. So let me.
Marianne.
Yes.
I see one the last question in the chat box: how the Secretariat provide technical assistance to control emission flow for coal power plants, and I'd like to mention that the Hanoi workshop I talked about it was made possible by the contribution of the European Commission and also the China Trust Fund. And that project is ongoing. We had planned to convene further technical workshops, but we haven't been able to do so because of the COVID situation. So we would be happy to learn about the needs from the parties and provide technical assistance in cooperation with the Global Mercury Partnership. Thank you.
Yes, and Eisaku, thank you. And I know you have to leave for another meeting right away, but so the final question I can send to Lesley, but it is, if activated carbon is used as an adsorbing agent in flue gases, the mercury in the ash increases. Besides, what is the leachability of mercury from this ash? Lesley, can you take that one?
Sure, I can give it a go. Yes, the mercury will stick to the activated carbon, and it depends which activated carbon you're talking about. If you're using activated carbon specifically, so you're capturing that as a waste stream, then you can deal with that, and it's taken away as a toxic waste and dealt with specifically. If it's the activated unburned carbon in the ash and it's taken down in a baghouse or a fly ash capturing system, then there's a chance that if there's not too much carbon in the ash, they could still use that in a cement situation. Very unlikely. Cement situation will only use ash if it has a very low carbon content, so it should not have enough mercury in that for it to be a problem if it's used on a cement basis. When we're disposing of the waste, there have been many EPA studies that will that confirm that the leachability of mercury from activated carbon in fly ash is very low. And we've not seen any issues with it leaching out and causing environmental damage. However, I've not read all the papers, so perhaps there is an example where there has been an issue. However, as far as I'm aware, there is no problem with mercury leaching from activated carbon.
Thank you. Eisaku, anything you want to add?
No, I think so. It's a very good explanation, and I have to leave now. Thank you very much.
Yes, thank you. Okay, well, I think we've wrapped up right on time. I want to thank everyone for your participation. And again, all this information will be posted on our website, and we're happy to answer questions that you send to our Secretariat email box as well. I want to thank Lesley and Eisaku and Monika for your leadership of this work. And with that, I think we can close. Have a good day, everyone, or evening.
Thank you so much, colleagues. Thank you, everyone. Bye.